Hello everyone, and welcome to a walkthrough and demonstration for the installation of the OpenWeedLocator software onto your Raspberry Pi. Today I'll be taking you through the two-step installation process, so cloning or copying from the official GitHub repository onto your Pi, and the second step is running the bash script al_setup.sh, which will automatically run all those manual commands to make it a little bit easier. So at this stage, if you're ready to follow along, you should have a Raspberry Pi flashed with the latest version of Raspbian. And you can do that with the Raspberry Pi imager and a micro SD card. I'll link to the GitHub description where you can where I talk through that process. But there are some fantastic videos on YouTube out there as well that will help you get yourself set up to this stage. You'll just need a screen connected, ideally, if you would like to see the camera output. Otherwise, you can run this installation through SSH or over SSH if both devices are connected to the same network. So to kick things off, we want to open up a new terminal window. And I should mention this Raspberry Pi is pretty well untouched. I've just done an update to it so it doesn't interrupt the recording, and I've also installed a screen recorder. But what you see here is, or should be, quite similar to what you see on your device as well. So to start, we want to clone that repository. So git is our tool, clone is the command, which basically just copies from a specific URL. And to get that URL, we just need to go to our web browser, search up OpenWeedLocator, and click on the top link, and just copy this URL here. You can also find the URL to the GitHub link just there. And we go back to our terminal window, paste that URL in, and the final command or argument we need to give this tool is the directory where it should be cloned into. So we want to call that, and we should and have to call that al. That will make sure everything runs correctly. Press enter and it should start downloading. If you do have some internet issues, you may find errors here where it breaks halfway through the download. Just try redoing it and seeing if that works. If it has downloaded half, it may come across an error where it says there's an al directory that already exists, and you just delete that and then start again. It's also important that we are using the username al or OWL at Raspberry Pi. You can use your own username, but it can cause a few things potentially to fail. I've tried to make the code as robust as possible to changes to username, but sometimes it isn't always possible. So just to keep things simple, I would recommend setting the username of your device to OWL. So now we have that copied or cloned into the home directory. So you can tell you're in the home directory with this little squiggle here. And to check it's being downloaded, we can press ls, so that's list. And you can see that we have the al folder that has been cloned. So we can change directory into the al folder using cd al. And now we are in that home/al. And if we press ls, type ls again here, we should see everything inside the OpenWeedLocator directory, including the important one that we'll be using today, al_setup.sh. You can also get here using the file structures, just using the user interface. So here's our home folder with the OpenWeedLocator directory. Double click on that. And then here are all the folders that we can see and files that we can see here. And there's al_setup.sh. If we open up this file, we can see what's going to happen. We initially set up some variables in the environment, track some errors. Then down here is where we actually start doing what you would otherwise type. So basically it goes through line by line, and instead of you having to type it, it will do it for you and check that it has occurred and happened correctly. So if you'd like to, you can do this manually. There is a step-by-step process as well on the GitHub. So we can close that. We can close this one and then close this one as well, and we can go back to our terminal window just here. Right, so all we need to do is type bash, which is the tool, and then al_setup. One neat trick is if you press tab, it will complete the line for you. It will save me a lot of time, but you just need to type al_setup.sh, which is this file here. and then press enter. So what you should see as it goes through is are these green lines that indicate what it's doing at that stage. So here now it's just updating and upgrading the system. Now it's testing the camera, so you can see a live feed as it runs through just to check if the camera is connected and working. Then it's doing some removing some unnecessary packages, setting up the virtual environment now by installing virtual env and virtual env wrapper. That's been completed successfully. Now it's set up all the different scripts correctly and added itself to the bash RC script, and it's created the virtual environment owl now as well. Now it's installing OpenCV, which is the fairly critical computer vision package for Python, and it's installing it into the owl virtual environment. So virtual environments are really nice to keep all your code and your packages in one environment, I guess, or one little location that's separate from everything else. So you can have multiple different environments that don't necessarily interact with each other. So say if one package upgrades and it causes havoc with another one, you don't ruin your other environment just in case. So on the Raspberry Pi 5, it actually prevents you from installing into the global or the whole system. You have to use environments. And so that's what the OpenWeedLocator or OWL environment is doing there. So that has all completed successfully. We can check down here, okay. It's all green, everything's been done correctly. The final steps were just installing some requirements into that same virtual environment OWL, and also moving the boot scripts into their locations and adding it to the cron jobs that will start on boot every time you start this up with or without a screen. And then finally, setting the desktop background. So you can see or go straight to the GitHub page just there, and some important commands if you want to update your OWL a bit more easily. So that's pretty much it for the installation process. Now we can do things like focusing and testing out the system. So there's no OWL running at the moment, but what we'd like to do is perhaps improve the focus of the device. So start OWL focusing, we press Y and then enter, and that will turn the camera on. And there you go. There's the video feed from in front of this camera. And you can see the LED lights in this room are causing a little bit of flickering. And also the white balance is not set to indoor lighting. That's why it looks very orange. It's set to outdoor lighting. So it won't look like the camera you'll see when you run this outside. The blurriness is a value you want to maximize. So this doesn't look too bad. I'll probably leave it as is just so I don't bump anything. But you want to maximize that blurriness value. Low blurriness values means there's more blur in the image and it's not as sharp. This isn't too well focused. It's also quite close to the camera. But ideally you want to take this outside and set it at the distance about 1 meter off the ground that you'll be using it at in the field. So closing that now, we press escape. And escape will work when you're selected on the screen. So if you click away from the screen, then escape will not work. But if you click on the video feed, I should say, and press escape, then it should close. Then we can launch the OWL software if we want to. That will just bring up the same window but without the focusing. And it should run a little bit faster because the focusing algorithm does take a little bit of computational power. I won't do that right now because what we'll do is reboot instead. So click N. And then so there you go. You can click run ./owl.py --show display if you'd like to launch this later. And that's the installation effectively done. Now we want to see if it works on the startup. So instead of having a screen connected every time and having this terminal window open and you running it yourself, it's much more efficient if you just give it power, give it 12 volts, and this thing turns on and starts detecting weeds. And that's how it should have been set up. And the way we can check that is if we just reboot. So I'll type in reboot and I'll see you guys on the other side. All right, so welcome back. I've just rebooted the OWL and the Raspberry Pi. And from the board I can see that's sitting on top of the Pi, I can see the green lights flashing. So that indicates to me that the OpenWeedLocator software has started on boot up, which is a success. So that's great news. To check that though, if you don't have one of these OpenWeedLocator driver boards or you don't have relays installed just yet, there is a very easy way to check. So what we can do is just open up a terminal window again. And if we go cd owl, so change directory into the OpenWeedLocator, our directory again, and then go work on owl. So now, when I was talking about virtual environments before, this is how you can activate that virtual environment and run the OpenWeedLocator software in that separate package or separate environment. Work on owl, and when you're in a virtual environment, you'll see it at the start of each line in the terminal window. So here it says owl inside brackets, so we now know that we're inside that owl virtual environment. The next step is to run the software. So if we go Python owl.py, and to show the display, so we can see what the video is seeing, we just need to press -- show - display. There we go. So we press enter here. It will try starting up, and it should throw an error. So that's because in the background the camera is still being used, and so are the other GPIO pins. So what this error will tell you is, firstly, if another owl process is running, which it will tell you up here, and it'll throw an owl already running error. And then it'll also tell you the program ID or PID of that particular bit of software. So this one is 763. The second one down here is the one I just typed. So that should have stopped already, but if you want to be sure, you can kill them both. To stop them, you just type kill and then the PID, so kill 763, which will stop that immediately. So if we go kill 763, then there should be no more owl processes running in the background. And I can confirm that because in front of me, the green lights have stopped flashing on the owl driver board. So to run that again, now we know that it had started on boot, so we can confirm that it was working correctly on startup. We can type this again and go Python owl.py -- show - display, and it will give us that screen from before. And this time it's picking up my solder as a weed, which is great. So that's turning on one of the relays, and you should be able to see in the terminal window here as well that nozzle 3 has been activated. So the software is working as intended now. So this is all set up as default. Everything is ready to go. If you want to restart this without any screens attached and with your solenoids connected, it will start working. There's nothing else you need to do from this point. From here on in, though, I'd like to just take you through some of the different features and things you can do with the OpenWeedLocator, some of the configuration files you can change that hopefully help you in the future if you want to come back to this, and if you have issues or perhaps you want to change a few of the settings yourself. Now, the first one is that pops up each time, and you might have played around with this already, are these thresholds just here, so just detection thresholds. So we have 3 windows that come up when we type that owl.py -- show display, and they're the video feed, the detection output, and then on the right-hand side we have the processed image output. So this is based on the OpenCV thresholding using excess green index and an HSV thresholding. So within the HSV color space, hue, saturation, value, there is a thresholding done as well, and that's the XHSV algorithm. You can change that algorithm if you like to XG or just HSV, but our research has shown that XHSV seems to be the best. It does require a little bit more computationally, but it's well within the bounds of the Raspberry Pi, particularly the Raspberry Pi 5. But down here you have the adjust detection thresholds. So for each of these thresholds, it will change how much of the weed is detected, or how much green, or how many other colors is the software sensitive to. So for XG min, if we decrease this, we can start to pick up other colors, I guess, within that part of the spectrum. So excess green multiplies the green channel times 2 and then subtracts the blue and the red channels from that, so it amplifies the green signal coming in. But because we're running an HSV thresholding on top of that, then we don't see too much change in that. But if we do change some of these hue values, you should start to see a lot more weeds, in inverted commas, be detected. And you can also potentially start to detect things that are red, not really green. Although red is a bit difficult because it sits either side of the spectrum. So then you can do blues or whatever color you like. If you press S, it will save these thresholds to file. If you don't, it'll just go back to default. So if you're just playing around with it, probably not worth saving it. So that will change your color threshold range. So say if you want to detect slightly less green weeds, maybe they're struggling through a hot summer, and you want to try and pick up ones that are not quite as green, you might want to lower the hue min and increase the hue max a little bit. Usually it's about 35 or 30 to 80 to pick up those bright greens. The saturation is how strong that color is. So we often screen out the really undersaturated and really oversaturated colors because there are a lot of false positives you get when a really bright sort of white reflection comes off stubble. And so this is a way of filtering out some of those reflections. But again, if you increase these, perhaps not under this light, it does depend on the lighting conditions. But you can see brightness is obviously a big one that's affecting detections as well. So you can change the minimum maximum brightnesses too. So eventually you should be able to detect everything. And you can see on the right-hand side here that HSV thresholding is slowly changing as we detect more and more of the image. And there you go. So they're how you play around with the detection thresholds. So you press escape and it won't save those settings. So the next thing we can do is actually try detecting a series. So if you have a folder of images, you can supply that in the command line here. You can also supply a video file or just a single image, and it'll keep looping over that. So if we type in, let's double check what the commands are. So if we go into owl and then OpenWeedLocator.py and click open, because this is an executable, it happens on boot, just click open and not execute in terminal. And we can see our options and what it does in the code down here. You can also type help, --help, and that will print these out beneath on the terminal command line as well. But here you can actually see how it's interacting with the Python. So when we type --show display, what it does is sets this to true instead of false, and so those video feeds come up. When you type in --focus, that will bring up the focus window with that value, the blurriness value that you're trying to maximize. And again, it's just a simple true or false. With the --input, what you can do is add a path to your images or image directory that you want to try. So again, just images, videos, or a directory of images. So let's use input. And to download some photos first, we'll close this. We go back to our web browser. And a good place to get some images from is WeedAI. So we type in WeedAI. That's a project we helped develop at the University of Sydney to try and standardize the sharing of weed images. And it makes it a little bit easier to find and download. So here's the main screen. We can scroll through a range of different data sets are available. I think there's about 30-odd thousand currently. So to select fallow, so we just want fallow weeds, we click there. And then this will bring up all the data sets of weeds in fallow conditions. That will be a good test for the OpenWeedLocator software. Some of these are quite large data sets. So for example, these ones, if we go C dataset, that's the cottonweed det12, which I think is quite a few thousand images. This one here is something I've collected, Danish thistles, it's about 200 images. So we click C dataset, and it's of Danish or thistles in a few Danish fields. And what you want to do is just click download in WeedCocoa format and then extract it to whichever directory you'd like. So I've already done that. This does take a little bit of time. It's about 700 megabytes. But you can go through any of these images and download whichever ones you'd like to play around with, or perhaps you have some of your own. So we'll close this again, having downloaded that data, and we go to home, and you can see in test images, this is what's downloaded. You have the annotations in the WeedCoco format, and also the agricultural metadata, and then also the 243 images here. So what we can do is copy path to this image, and we can try running that with the OpenWeedLocator. All right, go back to our terminal, and so we type Python. So just confirm we're in the owl environment, owl folder. So Python owl.py -- show display input. And this is where we paste the path to that image. And then click enter. And there you go. So that's the image that I clicked on. And you can see it's picked up the thistle and also some of this green moss that's surrounding the thistle as well. So you can also see some of the shortcomings of just green detection, because of course you may not necessarily want to spray the moss. You just want to spray the thistle. So we can see that we can add an image. You can also add a directory. So if we just copy this path here, so Python owl.py -- show -- display input, and then paste. And this will just cycle through those images. And then you can see it's picking up some of those large green areas. So it should have, I think, about 5 to 10 seconds per image to pick up those weeds. And you can see the weeds that are sticking out just here. So you probably want to tune this to in some extent, although, again, moss is always going to be detected because it's a very strong green. But it's not doing a too bad job of picking up those the actual weeds in that photo. So we can press escape, and it'll just keep iterating over that folder. So that's one feature of the owl. The interesting or potentially quite relevant one is the config files that you can change. So if we go back to our home directory and go to the OpenWeedLocator directory, then we go into config, and by default it will use day_sensitivity_2. So that's what it will read from by default, but we can change the one it reads from, or using the controller, we can actually select a sensitivity on the fly, so you can change between low and high settings. But we'll open this one to start with, and just scroll down. We can see what's inside. So it starts off with the algorithms. Say you want to try a different algorithm, you can try things like XG, HSV, and they're the ones that are supported and probably the most useful at the moment. This is where you can type in your directory, same as what I just did previously at the command line. Relay number is how many are connected to the owl. If you decrease this to 1, 2, or 3, that's fine. It will default to the lowest relay value down here, so 1, 0, 1, 2, or 3. Otherwise, if you increase it, you'll of course have to add more relays, and you will need to add a greater number of relay channels as well down here that it talks with. You have actuation duration, so this is how long it sprays, and this is the delay between finding the weed and then spraying it. I set that as 0 because generally the delay between detection, actuation of the relay, and then actually spray getting to the weed is about right if you're operating at 10, 15 kilometers an hour. If you build a controller, you can type the controller setting in here, so Ute Advanced, and just with any of these, avoid using spaces or any quotation or apostrophes. For the advanced controllers, these are some of your settings. Again, you can see the low and high sensitivity with the switch if you switch it to an up and down. Mute controller, same thing here for recording and the switch pin. So if you do detection, you can toggle detection on and off, or if you type in recording, it will toggle image recording on and off. This is that loop time, so 5 seconds per image. This is the resolution of the camera system. So you can increase this. I would just warn against increasing it above probably 640 by 480 on anything probably below the Raspberry Pi 5. It does work with the Raspberry Pi 4, but it is very, very slow. On the Raspberry Pi 3, the Plus, we have caused some of the SD cards to brick. Basically, they become a nice bit of plastic if you go too high in this in resolution, because it just overloads the system. But you can do relatively high resolution with the Raspberry Pi 5, and it still performs well. So, for example, if we want to go up to, I think the full resolution of the camera is just here. So 640 by 480. It looks like I can't quite see the camera resolution in here. Oh, that's from it was from the input files. That's right. So if we typed in, it's also something worth knowing. So if we type in python out.py -- show display, then we'll bring up our screens again. And because now the camera is connected, we can see the image sensor, which is IMX296, the global shutter. We can also see the maximum resolution and the resolution we were actually using and the image format, which is RGB and 888. So the maximum resolution we can give is 1456 by 1088. So we'll try that. It'll run very slowly. Save this and then run here. And they are very large. It does resize this back down to a visible part of the screen, but as you can see, the resolution is much, much higher from this HSV thresholding window just here. And as you can see, it's also running very slow comparatively. But it will run. Okay, so now you can see how to change the resolution. So we'll go to back to 640 by 480. This is in development, so we are working on the green part. These are the parameters you can change in the adjustments, but if you want to set them permanently, so every time you start back up, this is where it reads from. So what you can do is save them. You can test them, save them, and then want to change them here to make sure it actually runs every time you reboot the system. Data collection is quite useful. So what you can do is sample images, and every 30th frame will be saved to a connected USB drive. It will only save to a USB drive. If you type this in wrong, it will eventually find the connected one. But if you don't provide a USB drive, it won't save it to the disk, just in case it keeps on saving until it fills itself up and then causes problems. You can also disable detection. So I recommend, if you're just using this for data collection, set the disable detection to true. So there's no more detection happening. And that way it will be much faster and more reliable with the image saving itself. This is an interesting one, so log FPS. So it'll print out how many frames per second or how fast it's processing the images that come in to the terminal. So if we type that to true, Control save, and we'll run this again. We can also do this without show display. And you'll see it just start the camera, media source successfully set up, and it will just wait for that first FPS value to come back. And it saves it every 900 frames. I think it will do a check-in. So the faster your frames per second, the faster you'll see that value flick up. There you go. So it's approximately doing 44.7 frames per second at 640 by 480 on the Pi 5. And that's also running recording and also running the screens attached. Without all of the additional material and also the computational complexity of recording video, it's usually about 60 frames per second with 640 by 480. So you can afford to actually increase resolution on the Raspberry Pi 5 up to about 800 pixels, and then it starts to decline to about 30 frames per second. If you go slower than 5 or 10 kilometers an hour, you can probably increase it even further, depending on your approach or what you're using this for particularly. And so to cancel this, we press Control C, and then it'll shut everything down. So we want to turn that off, go back to false, save. And then finally, this is something you probably don't really want to touch unless you're changing or adding more relays to the system. So even if you decrease, you only use this to control one relay, it'll just use the GPIO pin, board 13. If you use two relays, so the image is split into two zones, it will just use 13 and 15 by default. If you use 6, 8, 10, 16 relays, I've connected to this before, then you just keep adding lines here until you max out the number of GPIO pins on the Raspberry Pi. And just remember to change the relay number up here as well. But that's effectively the configuration file and pretty much everything the OpenWeedLocator has to offer. So if you do come across issues, feel free to get in touch through the issues on the GitHub page. So go to that URL we had before and the issues tab, and then write an issue there, or send me an email. And there are some things you might come across. Hopefully they've been more explicitly recorded here, and also some of the error messages are much more clear. So hopefully it does help a little bit. But if you do have suggestions, you come across errors others haven't found, there can also be updates that cause breaking problems like I found recently. And that's much easier for me to find if other people can let me know as well. So I appreciate all your support on the project, and let me know if there's any other questions, comments, and please get in touch if you have any suggestions or ideas on what we can do in the future or how to make it a bit better. Thanks for tuning in. Until next time. Cheers.